Let's prove that odd of R over Q is equal to the trivial group, that the only automorphism of R over Q is the identity function. So the strategy for our proof is to use the following fact. If f is a function from R to R which is continuous, and the restriction of f to q is the identity, so that means that f of q is equal to q for all rational numbers q, then f is itself the identity. So we mean that f of r is equal to r for all r inside of R. So in other words, if f is a continuous function and f is the identity on the rationals, then f is actually the identity everywhere. So to remind you of why this is true, let me briefly sketch a proof. So proof sketch. And it goes as follows. Any real number r can be written as the limit of a rational sequence. It can be written as the limit of a sequence of rational numbers. So let's go ahead and do that for a given r. And we see then that f of r, just by definition then, is equal to f of this limit of rational numbers qn. Now by the continuity of q, by the f's continuity, we can move the limit out of the parentheses here. So f of this limit of these qn is equal to the limit of f of the qn. That's just by the continuity of f. Okay, but now we know that f is the identity on the rational numbers, and every qn is a rational number. So this is by the fact that f restricted to q is equal to the identity. So f of r is equal to this expression, which is equal to this limit, which is equal to this limit, right? F of qn is equal to qn, which is equal to r. So f of r is equal to r. Okay, so that was the sketch of this fact. Sketch of this fact here, or a proof sketch for this fact. Now what we'd like to do is use this fact to prove the claim that we want. We'd like to use this fact to prove that odd of r over q is equal to the identity. And you can guess what the strategy here is going to be. Let me spell it out. So now our proof strategy is as follows. Proof strategy is as follows. We'd like to show that the automorphism group of R over Q is equal to the trivial group. The identity is the only element in it. So in other words, we want to show that if we have any field automorphism of R, which restricts to the identity of Q, then that automorphism is actually the identity of R. So if sigma is an automorphism of R which restricts to the identity on Q, then sigma is actually the identity on R. Now by the fact above, we know that it suffices to show that sigma is continuous. Because if sigma is continuous, then sigma is a continuous function which restricts to the identity on Q. And by the fact above, that's enough to show that sigma is the identity on R. So this is really the key point. By the fact above, it suffices to show that sigma is continuous. So that's what our strategy is going to be. We're going to try to show that any automorphism of R which restricts to identity on Q is in fact continuous. So here's how we'll do that. We'll do it through a series of smaller claims. So here's our outline. The outline is as follows. Again, remember that we're trying to show that any automorphism of R over Q, any sigma inside of aught of R over Q, is actually a continuous function from R to R. And here's a four-step process for doing this. So first, we notice that a real number is positive if and only if it's the square of some non-zero real number. So little r inside of R is positive if and only if R is equal to s squared for some non-zero real number s. This is a fact which you probably know. Okay. So what we want to do is use this fact to translate an order property of R into an algebraic property. This is kind of where the magic happens between these two steps. So we have this order property of R, this sort of positive property, and we can change that into an algebraic property. And the way we do that is noticing that sigma of s squared, by the automorphism properties of sigma, is equal to sigma of s squared. So sigma of s squared is equal to sigma of s squared. And that tells us that if R is a positive number, then so is sigma R. Now there's a little bit of work to do, going from this step to this step, and that's going to be true in all of these steps. I'm sort of not going to spell everything out, I'm just going to give an outline. So you may have to stop the video and fill in some details at different points. Okay, but assuming that, we now know that sigma takes positive numbers to positive numbers. Okay, so then the next claim is that by using the other automorphism property of sigma, by using the fact that sigma of A minus B is equal to sigma of A minus B, we can then conclude that if A is less than B, then sigma of A is also less than sigma of B. So this is nice because we now know that sigma preserves the order of R. So if A is less than B, then sigma of A is less than sigma of B. Sigma preserves order relations. Now this is nice, right, because we've taken the algebraic properties of sigma and turned them into some pretty topological properties. So we're essentially done at this point, because now we can notice that if the absolute value of A minus B is less than n, or 1 over n, so in other words, if the difference, or the distance from A to B is less than 1 over n, then sigma of A minus sigma of B, the distance between sigma of A and sigma of B, is also less than 1 over n. So that takes a little bit of work to see, to go from this step to this step, and to kind of translate things around here, but you should be able to do it. Okay, and given all of this, we can conclude now that sigma is a continuous function. Alright, so again, this was just an outline. There are some details you may have to fill in, or you may have to spend a little bit of time sort of understanding why something is true, why a given jump was made. But that's actually kind of good for your mathematical soul, to sort of go back and fill in these details and see why things are true, rather than having everything told to you perfectly explicitly. So I encourage you, if you didn't follow that completely, to kind of figure out what all of the links are and why these statements go through, to sort of fill out this proof outline until you're satisfied that the proof works. It should only take a couple of minutes, but I think that it's worth doing if you didn't understand everything the first time. Okay.